Hey everyone, it's Catherine. I just got this really great question. We have f of x equals x over x plus 1 and g of x equals 1 over x. Find FOG of x. Find the domain. First, let's find FOG of x. Now when I do these, I always rewrite it. F of g of x. That reminds me that I'm going to put g of x in here. So we'll have f of g of x. Well, what's g of x? 1 over x. Cool. Now what I'm going to do is I'm going to take my function f of x, and I'm just going to write equals. Now what I'm going to do is rewrite it with the parentheses around each variable. What am I going to put in my parentheses? This guy. 1 over x and 1 over x. So that's going to look like this. 1 over x all over 1 over x plus 1. That could be your answer, but if you're asked to simplify it, we do have to go a little bit further. Hopefully you remember that when you divide fractions, you flip the second fraction. And a friend just told me, she said KFC. I can't remember what K is, but flip and keep or something like that. Anyway, the problem though is we're adding and subtracting in here. So what we have to do is we have to find the common denominator here. Now I'm going to write it down here. Just the denominator. Now remember, the 1 is just 1 over 1. So what would our common denominator be? Well, I have a 1 and an x. Did you guess x? If you did, you're correct. So I'm going to make a little arrow here. So I'm going to put right here, common denominator is x. So I look at my first fraction. Well, I already have x in there, so I don't have to do anything to that one. I look at my second fraction. Now I need x in the denominator, so I have to put it there. But remember, whatever I do to the denominator, I have to do the numerator, or whatever I do to the bottom, I have to do to the top. So we have to put an x here. On a side note, basically what I'm doing is just multiplying by x over x, which is 1. So we're only really multiplying by 1. Yeah, it's kind of crazy. Now I look at it and say, hey, I have a common denominator. I can put it together, and we have 1 over x. I'm going to move my paper over here. So now we have 1 over x all over 1 plus x over x. Now what's really cool about this is we have a fraction over a fraction. Awesome. Now I have to move my camera here a little bit. I'm going to rewrite it here. We have 1 over x all over 1 plus x all over x. Now we're going to do our KFC thing. We're going to have 1 over x times, now we have to flip the second fraction, x over 1 plus x. Since we're multiplying, we just multiply straight across. Equals x over x times 1 plus x. Okay, now we need to simplify. Hopefully you notice I have an x over x. We are going to cancel those. Let me just get a different colored pen here. So we're going to cancel. And we end up with 1 over 1 plus x. And so that is f of g of x, or FOG, sometimes it's called. Now we're asked for the domain. And this sometimes trips me up. We have to look at the original functions. So look at original functions. Okay, so our original functions are f of x, I wrote g, and I said f. F of x equals 1 over x. And g of x equals, let me just make sure I see it here, x, oh my goodness, all right. Let me look back so I have it correctly. F of x equals x over x plus 1, and g of x equals 1 over x. All right, cool. Now, when we're looking at this, we don't necessarily care what's in the top or the numerator. unless it's something weird like a square root. But we have an x up there, so we're not going to worry about that. All we're going to do is we're going to worry about the denominator here, okay? I'm going to pause for a second and get another piece of paper. Okay, here I am at another piece of paper. We have x over x plus 1. Now, we don't have a square root in the numerator, so we don't really care what's up there. We're always only looking at the denominator. Now, we have to ask ourselves, what can we not have in the denominator? Okay, not have in denominator. And if you said 0, you are correct. We cannot have a 0 in the denominator. So I'm looking at x plus 1. Now, x plus 1 cannot equal 0, right? Well, what does that mean x needs to be or shouldn't be? Well, if you don't see it right away, we can use algebra. I'm going to subtract 1 from both sides of my unequal sign. That's weird to say. And then we have x cannot equal negative 1. So first of all, in our domain, x cannot equal negative 1. Now let's look at the second part here. We have 1 over x. Once again, we ask ourselves, what can we not have in the denominator? Well, we can't have a 0, right? So x cannot equal 0. We have our restrictions for our domain. What I like to do is I like to make a number line. Okay, and I'm going to put negative 1 in there, and I'm going to put 0. Now, since it's not equal to negative 1 and not equal to 0, I'm going to put an open circle there. Okay, we can't have that. But what can we have? Well, we can have anything this way, right? Anything in here, and anything this way. What's that going to look like? Where am I going to on the left? Like, what's happening? Oh, sorry about the strangeness here. But we're coming from negative infinity, and where are we going? Well, we're going to negative 1. Does it include negative 1? No. So we're going to have a parentheses. Then what we're going to say is union. Okay? And we need this middle stuff. So where are we coming from? Well, parentheses, negative 1 to 0. Once again, we're going to use a parentheses because it doesn't equal that. Okay? It doesn't equal that. And then union, where are we going here? Well, we're going to start at 0 and we're going to go to infinity. And you did it. Cool. Good job. Yay.